Yep. Okay, I'll get started now. Thank you so much, everyone, for coming. Yeah, my name is Kla, again, the CE and the lecturer. And today, this is Fit to 107, software quality and testing. Last week, we talked about introduction to software quality assurance already. I hope everyone enjoy the first week studio so far. Okay. There are a few things that probably before I start the lecture, I just want to remind you about this one. Just recap. I post the week 2 announcement here. All right. Yeah, so all of the materials are now available online. Just want to confirm that we will do the online only lectures. So because the on-campus seminar is optional, that means I will, because I have the streaming facilities at home, so I will teach from this place and do the record. And yeah, because I have lots of monitors here as well. And in terms of the expectation, right, for the unit, just want to emphasize that students are encouraged to actively participate in the activities and tasks in the ED STEM. We often use the studios to provide feedback to achieve learning outcomes, right? And because in the unit, right, we will cover both the concept and the practices. So from the week 2 onwards, which is this week, we're gonna be more hands-on in the doing the unit testing as well. Okay, and yeah, so that means students will have a chance to design the test case, write the unit test, and then execute them. This is one of the feedback that we get from the first week. Thank you so much. And in terms of the activities here, right? Because when we use the ED step, we can track the activities for each student as well. I encourage everyone try to participate in these activities as much as possible. Then you will be a master in software quality testing. You'll be the real expert if you can pass everything. Okay. Yeah, so these activities include the practice to test your knowledge and analysis, improve your analytical thinking skill as well. Yeah, and from this week onward, we will do some hands-on to write the unit test. There are 2 questions in the quiz so that are a little bit confused. Okay. First, question 8 here, verification is focused on ensuring the software is built correctly, while the validation is focused on ensuring that the software meets the user needs. Yeah, so actually the answer to this question should be true. This is just to follow the week 1 lecture slide. And for the question 9, in the waterfall model, when does software testing typically occur? So this one is quite tricky. There are both answers, right? After the completion of the coding or at the end of the development process. It can be either one may be correct. It depends on the context as well, but definitely, of course, after the completion is done, this is what happens in the waterfall, like 100% correct. But it could be at the end of the development process as well, if and only if that there's no other phase in the waterfall model, right? So that means we can do design. Let's say in the waterfall, it depends on the practice, because for this one, the question is not clear, like how many steps in the waterfall. Let's say if we have only design, analysis, implementation, and the testing, yes, for in this case, the answer is still correct. But let's say if we have, what is that? Maintenance phase as well, right? So testing cannot be done at the end if we do design, analysis, implement, maintenance, and the testing. It's not like that. Normally, testing is done after the implementation. Okay, so that's the key point here, which is the other way around when compared to the test-driven development. Mm-hmm. And for the first week, we also run a survey as well, right? And thanks a lot, everyone. You are so wonderful. We received over 100 responses, and we try to take your feedback seriously as well. Some of you suggest that the first week studio is quite lengthy. So right now, the week 2 will be more packed. Okay, it's more hands-on and more fun as well, more challenging. I hope that everyone will enjoy. Okay, go to the lesson. This one for the studio. Okay, I already up for the lecture. I already upload the lecture slide. And during the studio, we will do 6 tasks here. The first 3 tasks will be more analysis, more thinking, and quiz, test your knowledge. But the last 3 tasks, 4, 5, 6, will be the coding challenge. Okay, so that means student will have a chance to implement the test case, practice how to test a function as well. Let's say this is a multiply function. This will give you a guideline step by step to run the unit test here. Okay, but we will cover about unit testing later as well. This is just one step at the beginning, but from the week 3 onwards, it will be more challenging. Okay, and more fun as well. So I highly recommend everyone should participate in these activities in order to successfully get the full mark for the assignment as well. Okay, yeah, the first assignment will be will cover the materials of the first 3 weeks. Okay, for example, quality attributes test plan and the unit testing CI/CD, yeah, which will be next week. All right, we will get started now. Any questions so far from this in the Zoom? Let me try to check. Nope. Okay, cool. Thank you. So today we will talk about the introduction to software testing. All right, and basically we just try to explain what is the 4 levels of the testing, why it is so important, why do we need to do the test plan as well, and what are the steps to be a software tester. Right. So the key point here, we will, after you complete this unit, how can I say, like for this unit, I already designed the materials as a journey to be a software tester. So once you complete this unit, you will perform like a software tester. You will practice every activities. Okay, that's the key point here. And software testing, what is that, right? Look at this one. If you don't know how your code works, it does not work. So you just don't know it yet. So that's why most of the time when we implement the software, but testing is very hard. If we don't know what is the requirement, how the program works, we don't know how to test it properly. Because when we write the test case, we should have some expected output, right? Let's say if we want to test the multiply function, 2 multiplied by 3 should return 6. Yeah, but if we don't know what is the mechanism inside the multiplication function, then we cannot test anything. That's why most of the time testing activities consume more than half of the software development cost, and it is very time consuming, labor intensive. That's why we need a systematic approach, the right approach to decide the test case and develop the plan, okay, effectively. Yeah, when we test the software is very large, from the UI until the unit function, right? And when we in the week 1, we already talk about validation and verification, and there are different levels of the software testing, starting from the lower level to the higher level. Okay, to the lower level, that normally we call unit testing. So basically, unit testing, we just break the software into the unit function, the smallest module. And we have the argument in the function, which is the input, right? And then we want to test if the input is this, what are the expected output, and whether the actual output is the same as the expected output or not. That's how we test the unit. Integration testing, that's when we test different functions or methods together, similar to the system level system, that's including the non-functional as well. Okay, functional part, we focus on the unit testing. Integration testing, system testing, we focus on the non-functional as well. Okay, but the software that we produce may not meet the requirement or the end user need if we don't do the acceptance testing. That's why the purpose of the acceptance testing is to test whether the end users are happy with the products that we deliver or not. Okay, that's the 4 levels of the software testing, and within this week we will cover both as well. Okay, all of them, unit testing to the acceptance testing, but normally we start from the acceptance testing. Okay, the goal of the software testing, all right, is simply to eliminate the bugs, okay, the bugs, fault, errors, and the failure. We want to get rid of this. We don't want to produce the software that is full of failures. It costs lots of money and the reputation to the software companies, as we mentioned before. And surprisingly, these 3 terms are very confusing, right? Like we just use it interchangeably, but actually they are not the same. For example, when we talk about fault or flaw, it means that it is the mistake in the coding, in the design, in the implementation. Let's say if we implement the multiply function, right? Multiply function, and if we return a plus b instead of a times b, then that's the fault in the code, in the program, in the software. That's a fault. But what are the bugs here? Bugs is the runtime error. Okay, bugs is a runtime error. It is the thing that happens during the runtime. For example, if the input is the 2 and 3, if the program again multiply function, right? If the program returns, if this function returns 5, that's the error in the code, okay? Because of the fault in the line return, okay? That's the thing, okay? And the failure is the runtime manifestation of an error to the program, external to the program. So what happens to the end users? That's the failure. Because the multiply function is buggy, there's an error in the multiply function. That's why it causes let's say miscalculation to the banking system, and it costs a lot to the bank, something like that. Okay, let's say this is like a banking system. Okay, and if the multiply function is wrong, they may miscalculate the interest rate. They may miscalculate the balance of the account, the transaction account or saving account or whatever, right? So that's a failure to the end users, to the customer. That means customer, one of the failures is that customer may be dissatisfied with the mobile banking app products, that kind of thing. Okay, yeah. Okay, but if we get rid out of the fault, errors, and the failure, that means we can successfully deliver the software system. Okay. Any questions so far? Is it clear or not for this point? Maybe yes, then say yes in the Zoom chat. Then I can proceed. Move to the next slide. Yes, thank you. Thank you. Okay. Yes, thank you. Okay, so a few more examples, right? When we talk about data validation in the form submission, which asks about age of the users. Okay, what could be the potential, what is that? The fault, error, and the failure. Okay. We talk about error and the failure here. Okay, so error could be if the form accepts negative values of the age. That's the error. Age should be at least 0 to something, right? Let's say 100 or 120 years old. Okay, so that's the error. If the form accepts negative values, that's an error in the program. And if the program cannot handle such kind of invalid input and it crashes to the end users, that's the failure of the program, right? The program cannot handle or throw the error message to the customer, so they don't know what's wrong. Okay, that's a failure. Another one, payment processing feature in an e-commerce application. So let's say when we place an order button, when the place order button is clicked, If the system calculates the total amount due incorrectly, but it proceeds to the payment transaction, that's the error, okay? That's the error. But if the system encounters an internal server error and fails to complete the payment transaction, that's external to the end users now. That's the failure, okay? Error just within the program, okay? Whatever happens within the program, but failure is the external factors, external to the end users. Okay, that's the key difference. Okay, but when we do the software testing, this is Dijkstra. He mentioned that testing only proves the presence of the bugs, but not their absence. When we design the test cases, we discover the bug. That's what we found. But there may be some unknown bugs in the software as well, right? This is the point that the one of the limitation of the software testing as well. We can only prove the presence of the bugs, but not their absence. So that means even if we exhaustively test the software, we may not provide like a 100% guarantee that that program is fault free. Okay, we cannot say that. Yeah. Okay. Until we do some acceptance testing, not really, but I mean, if the customer happy, if the end users happy with the software products, it meets the acceptance criteria, then they are fine, right? Okay, in reality, software is very large and complex, right? Think about like, what is that? Let me get some annotate here. Draw, okay. Okay, actually we got some question. What would the fault be in those examples? What do you mean? Again, can you open the mic and say something? Or no? The previous slide? Okay. This one or the one before? The one before. Yeah, this one. Fault. The fault could be, right? So for this one, the form accepts negative values. That means the fault here, maybe the program does not have any mechanism to check the input validity. That could be the fault in the, not really the fault, but if the program cannot handle it, it can throw this error to the end users, okay? Yeah. Yeah, so that means just to clarify, maybe for this case, maybe there's no fault here, okay? Because the program just take the age, right? But if the program take the age but return the other values, that's the fault. But for this one, in this context, the program can take the age correctly, but the program cannot handle invalid input of the age values. So it can throw the errors or the failure to the end users. Okay, make sense? Okay, thank you. Yes. All right. Yeah. So testing is very hard and complex. Okay, think about this one, right? Like in real world scenarios, one piece of software connected to the there's a web app, desktop application, mobile app, and or tablet application, right? And that's the front end, but the back end, there will be like a lots of business logic, data access, database, lots of data tier, the web server, that kind of thing. So there are lots of pieces of coding around one software products, and you know, in reality, requirements are subject to change. And when we have one small change to this, right, it will cause like how can I say, the repercussions. It causes a huge impact to the overall quality of the system. If the software is highly coupled together, tie it very much, right? And then when we implement one new feature, it breaks everything. Okay, yeah. When you do the assignment or in the next few practices in the studio, you will understand. If you extend a new feature, whether it costs or it break the previous program or not, right? So that's very challenging. Okay, you will face that issues later. And because in reality, the time and the resources are very limited, we cannot like test exhaustively. So how can we design and test, develop the most effective testing plan in the lowest cost? Okay, so this is what we want to do in real world scenarios. Yeah, that's why in terms of the project management, this is what we normally do in waterfall. We start from the planning and then we get the requirement. We write this one, right? SDP software development plan, SRS software requirement specification, that kind of thing. We do lots of activities, but the testing is just the step here, right? We need to do the test plan and test documentation before we do before we actually execute the test case. This is what we normally do in the waterfall model. Okay, but again, when software when the requirement is changed, we cannot go back to the requirement phase and change and that kind of thing. So it costs a lot. It's not the most effective approach. We're gonna in this unit, we're gonna be a little bit agile. Okay, focus on the TDD, test driven development. Let's say how to do. Okay, this is a journey of the software tester. Okay, how to test the software from the beginning. We talked about the shift left testing before. How can we integrate software testing at the early phase of the software development, right? And this is an easy, a general workflow that we are going to do together. For example, when we already have the requirement, okay, we have the requirement here. We normally analyze the requirement first. What are the how can we break it down from that requirement into the specific function? How can we design the software, design the class, design the OO program or whatever, right? And when we break it down into the smallest unit, then we will talk about how can we test it as well. That's the test plan. The next step, how to test each function, okay? What would be the valid input, invalid input? That's how we design the test case. Once we get the test case, we will execute it, okay? Implement it in the unit testing with the test runner, that kind of thing. When we discover the bug, we report it, okay? And then we keep doing, and then we release the software, okay? Release testing could be the acceptance testing at the end, right? Okay, let's try to do step by step, okay, together. So first of all, requirement analysis. Normally, as you can see, a mobile banking application here. This kind of requirement is quite similar to one of the tasks in the week 1 studio, right? That's the normal requirement. And then we need to identify which one is a functional, which one is a non-functional. When we decide, wait, 1 second. So yeah, requirement analysis. We break it down into 2 parts first. What is the functional and the non-functional, okay? And because different requirements require different testing approaches. For functional, we can do the unit testing, but for non-functional, we may need to use like another approaches, another tools and the techniques. For example, the load testing, vulnerability detection, performance testing, UI testing, we need to use like Selenium or that kind of automated UI testing. That's another story. We will not talk about that. In this unit, we will focus on the unit testing, functional requirement only, okay, from now, okay? Yeah, but to do that, what should we do, right? So from the requirement, we need to, how can we integrate the testing part to the early phase of the software development with the requirement here? How can we test it? For example, users should be able to register the mobile banking app using their personal information and create a secure login. With one sentence, we need to break it down into the step by step. Let's simulate yourself as an end user. What would you do to ensure that this requirement is met, right? So that one is called acceptance testing. Okay. Yeah. Normally, we need to translate the requirement to the user story first, and to the acceptance criteria, right? Because our requirement just say, what the software should do, but it doesn't say for who and what are the values. So that's why we normally write a user story. Okay, user story here. Draw again, Zoom chat. User story, normally we use this template to write, okay, as a someone, as a user role, as a customer, as a developer who want this requirement. I want to, what do you want to do, right? That's a goal that you want to accomplish. So that what are the values, what are the reasons here, okay? And once we get this user story, normally we just translate this, no, not translate. We need to come up with the acceptance criteria here. What the system should perform in order to meet this criteria. Okay, that's the acceptance criteria from the end user perspective. And sometimes people call is the definitions of done, right? Yeah. So what does it mean? It is a set of criteria that a user story or product backlog item must meet to be considered complete in Scrum. Okay, and we will try to work on this one together. Okay, let's see an example here. All right, an example. We will focus on the functional requirement number 1. Okay, users should be able to register for the mobile banking app using the personal information and create a secure login. So let's write a user story together. As an end user, okay, I want to register the mobile banking using this, okay, so that I can access my account securely. Okay, that's the purpose of this requirement. Every requirement should have its own purpose, right? And to write the acceptance criteria, this is one of the example. Imagine that you already have one mobile app, okay? You have the username field and the password field and the login button, okay? So what is the step of the acceptance criteria here? It should be completed, right? In order to ensure that everything, the user story, no, sorry, the requirement is met, okay? Okay, let's get started. The mobile banking app should provide a registration feature where users can enter their personal information such as this one, right? Okay, that's right. So personal information, it is linked to this requirement. The app should validate the enter information. Okay, that means inside when we do the coding, we should have the validation function as well. Whether the enter information is correct in the right format or not, right? When we talk about the email address, what is the valid email address? Does it, for example, it should have like the user name and the domain name. It should end with the ether.com, .net, .org, that kind of thing, but it should not be something else, that kind of thing, right? Display and should display appropriate error message as well. It's not just like if we provide an invalid input, incorrect incorrect email address, the program just crashed. That's not the right piece of software, right? It should provide appropriate error message. For example, your email address is in an invalid format. Please try again, something like that. Okay. If any required fields are missing or even is incorrect, yeah. So that's the validation function. Okay. That's as an analysis requirement engineer, that when you translate to this one, then developers know what to implement, what to write. So acceptance criteria is the key to the implementation. If we don't know, if we don't have this, we don't know what to implement, right? Upon successful registration, and this is like a scenario, yeah, like a step by step, you need to create a scenarios, okay? Start from the mobile app. Inside it perform the validation to check the input, right? Upon the successful, the user should receive email, verification email, SMS, blah blah blah. Okay, that's a very detailed acceptance criteria, and I highly recommend that everyone should do this. Okay, so we know what are the functions that are going to have, that we are going to develop, and how to decide the test case. But at the highest level, this is what the app should perform. Just only one feature, login. No, not login. Register to create a secure login. Okay. Okay. And this is an example too, right? And another one. Let's say if we look at the functional requirement tree, users should be able to view their account details, including balance, transaction history, and the statement. So that means after the login, I mean, think about the scenarios. After the login, maybe we present different types of the account. The user should be able to view their account details. Okay, yeah, account details here, including balances, okay, how many transaction history, and the statement, download the statement or whatever. So based on this requirement, sometimes in Agile, we need to write in a user story. As an end user, as a customer, I want to view their account details, okay, including balance, transaction history, and the statement, so that I can keep track all of my financial activities. We don't want to see that today we have $1,000, tomorrow have 900, and where it is, where it goes, right? So we need to keep track. It must have all of the history, okay? That's a transaction history. Yeah, and in order to test this requirement, how to do it? That means as an end user, they should provide a page or this kind of UI, right? And user should be able to see the current balance, that kind of thing. The account balance display should be accurately reflect the real-time update. Okay, that's the another requirement now. The app should provide this, should provide that. Okay, that's the more detail. Okay, yeah, you can check this one by yourself as well. That's an example of the acceptance criteria. Okay, and yeah, clear. Once you come up with this acceptance criteria, right? Then we need to decide the test case to ensure that how can we know that whether we already decide the test cases for all of the requirement or not, right? So that's why sometimes we need the requirement traceability matrix, okay? So it is used to ensure that each requirement has a corresponding test cases so that all test cases are linked to their respective requirements. Everything is connected together. It has a relationship, and then we know whether this test case is passed or not, and whether the requirement is met or not as well, right? And this is just a simplified version of the requirement traceability matrix for the mobile banking application, as I mentioned before. Okay, so this is just an example, right? But some other columns could be as well. For example, precondition, what are the steps to do? What are the expected results? What are the actual results? And what could be the potential defects ID, okay? Preconditions, for example, to meet this requirement, the user must be like a successfully logged in first in order to view the transaction. That's a precondition. If the precondition is not met, then how can the user can view the transaction details, right? This is an example. What are the steps to do? That's the acceptance criteria there. Expected results, that's what we want the program to be expected. And what are the actual, right? That's the documentation thing, okay? So that's the requirement traceability matrix. Once we know what is the requirement, we know the acceptance testing, then we can decide how the program is going to be. That's the step of the testing plan, right? We test the unit function, test the acceptance testing as well, test everything, system testing, integration testing, okay? So what is the test planning and how is it different from the SQA plan? SQA plan is just a broad documentation, a general documentation that describes lots of activities to test the software, right? SQA can include software testing part, code review policy, or whatever, right? But testing plan, we only focus on the testing. To test this requirement, this is a general table of content that we normally put in the test plan documentation. It looks quite similar to the SQA plan, but it is still different, right? Because it will tell you, let's say we write the test plan like this. Let me put this way. Let's say if I'm working in a company, okay, we develop a piece of software and then we hire a testing company to test our software, provide a quality assurance, okay, to this piece of software, the mobile app that I develop, but I don't have the capacity to test it, right? We hire someone, they are the testing expert. And during the contract, people often use this one as a documentation, as a contract. They need to tell us what is the context, what is the background of the app, what is their methodology to test it, what do they want to test, what is the assumptions, what is that business data model, what is the scope. That's a contract, right? When we hire someone to test our software, what is their test strategies, what is the plan, how do they track, and that kind of thing. And when we will finish the testing, that's the test planning, okay? Without the plan, would you pay someone, some testing company to, like, let's say $1 million, right? We will not, because if we pay $1 million, but we don't know what they want to do, then why should we pay it? So that's why they need like this kind of documentation. That's the value, okay, of the test planning. And to develop the test plan, normally these are the general steps, okay? Starting from analyze the product, decide the test strategies, define the test objective, define the test criteria, resource planning, who is going to test it, using which computer resources, just a CPU or GPU, which environment, different mobile apps or not, different mobile devices or not, and schedule and estimation. That's a cost. When are you going to finish? And determine the test deliverables, right? When we test the software, what is the outcome? Yeah. Yes, your software is good, one message or not, or just like detailed analysis. Which lines are tested, how many test cases, and how many lines are executed, how many test cases that are covered, what are the test criteria. That's the detailed things, okay? Yeah, test log, test result, I already mentioned there. Yeah, and to decide the test case, now we, again, from the requirement, we write the acceptance testing, we design the software, break it down into smallest function, smallest unit, method, that kind of thing, right? And then we, for each of the function, we normally have the input argument and the return output, right? So that's what we want to test at the unit level. That means, draw again. When we decide the test case, normally we need to itemize them as well. Whether this is a test case ID number 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, right? And what is the objective of this test case? We want to test whether, let me see, whether the input, the age input is valid or not, right? Age input is valid or not, to avoid the negative number, that kind of thing. The age, let's say the requirement here, the age should be at least 0, okay, 0 years old, year old. So it should not take the negative number at all, okay. That's the objective. And the input, right? So that's the age value now, 0 to something, okay. Expected output, maybe let's say gym eligibility. The gym only allowed people with 18 years old, okay? 18 years old, older than 18 years old to attend the gym. They are eligible for the membership, that kind of thing. So if the input is 18 and above, expected output could be true. Yes, they are eligible. But let's say if test 17, the expected output should be false, right? Yeah. Let's say if the function return the Boolean value. And then normally when we, this is the Python program, okay? Gym, we implement it here, and this one input the age, okay? And then we have a test case here. Normally we want to test it, okay? Return something, okay? And once we test this again, this is the method that we want to test, and this is the test file. Once we test it, we just want to compare between expected output and the actual output, right? If the program is incorrect here, then the actual output will be different from the expected output. Let's say if the input is 17, okay, expected output should be false. They are not eligible for the gym membership. But surprisingly, if the actual output return true, okay, so then we normally call this is a test oracle. Okay, we normally compare between expected output and the actual output. If they are the same, we call this test case is passed. If the output is different, we call it fail. That means the test case can be failed. Okay, but when we talk about the failed test case, there are two scenarios, right? First, the test case is incorrect or the code is incorrect. Okay, this is something that we need a human to verify as well. It doesn't mean that if the test is failed, the code is always incorrect. It's not like that. Sometimes test case can be incorrect as well. Okay, just something to let you know. And that's how the testing, how the unit testing work in general from the conceptual perspective, right? And whatever we do here, when we test, this is a program. Normally we call system under test. We can test the system level, the integration level, or the unit testing level as well. Okay, yeah, testing. These are test case. Any questions so far? Maybe a response in the Zoom chat would be great. If everything is all right, then all good. Thank you. Thank you. Thank you. Yeah, you are the best. Yeah, thank you. Okay, so once we write the test case here, right? Because one piece of software have, let's say, 100 functions, 100 methods, and each method can have both like many valid input and the invalid input. So there are lots of test cases for one piece of software. That's why we need to document it properly and describe it properly as well. Otherwise, it's not clear what is the purpose of that test case, right? If we name the test case like normally we need to write the test name, okay? Test method name. If we say test underscore 1, 2, 3, just itemize, we don't know what is that purpose. That's why we need to identify what is the scenario, what is the purpose of the test case, what are the preconditions, what are the steps, that kind of thing, okay? That's a general test case document. We need to document it. And these are the general format, okay? So normally when we have preconditions, it could be for the acceptance testing as well, or for unit testing as well. Let's say if we want to test access transaction history, maybe one of the input argument is depends on whether the login is successful or not, right? Is login successful function? It should return true in order to access the transaction history. It depends, okay? It depends on the context. That's the test case document, okay? Once we document it, we need to execute it. Without execute it, we don't know whether the test case is correct or the code is correct or not, right? So, because as I mentioned before, one piece of software can have like let's say 200 test cases. If we execute it manually, test the input manually, it takes time and the effort, right? And we should not do it in the real world scenario. So that's why we should use or need some help from the test automation tools or the test runners to automatically execute the test case, okay? Yeah, so yeah, the goal of the test automation is what? To reduce the numbers of test cases to be run manually, because the manual testing of overflow is time and labor cost intensive, as I mentioned before, and it is very slow and it becomes boring as well. You just execute like one by one, input hand by hand, following the document, right? It's not effective in real world scenarios. We should translate the test case from the document into the test code in order to automatically test the program. That's why we often use the test automation tools here, okay? And when we say test case, it's just one test case here. But when we have multiple test cases, it's called a test suite, okay? One test suite can have multiple test cases. That's a technical term that people use here, okay? And yeah, which test case to automate? High-risk business critical test cases that are repeatedly executed, test cases that are tedious, difficult to perform manually, test cases which are time-consuming, right? Oh, okay. So yeah, there are multiple types of test cases that we need to automate as well based on these, okay? So I highly recommend in real-world scenarios, normally we run the test automation in order to meet the requirement. It is very important. It is needed. Okay. All right. And because in the first slide, right, there are, how can I say, software is very large and complex, and there are lots of components to, there are lots of components in one piece of software. For example, the database, the UI, front end, back end, and there are different quality attributes as well, like performance, security, that kind of thing. That's why there are lots of tools here. And this is just a landscape of the test automation tools. To become a software tester, maybe one day you may need to be familiar with some of these tools, and we will use it as well. For example, okay, go through a few of them. This is at the unit level or integration level, right? Let's say if you write in Java, normally people use the JUnit, and yeah, that one. And what else? If you program using PHP, then you will use the PHP unit, right? And if you want to test the UI, okay, UI, normally UI can be automatically tested as well. We can use a few of these tools, okay? For example, Qtest, that's very famous as well. What else? Cucumber, this one is very famous, very famous. Most of people use for testing the browser, testing the mobile UI, that kind of thing, automatically test it, right? Acceptance testing, this is more like behavior driven now, or the UI as well. Some of these tools are very popular. For example, Selenium robot framework, Monash e-solution also use it as well. Capybara, this one is very famous as well, okay? Penetration testing, okay? So yeah, so some of these tools can be used as well for the pen testing. Performance, we test the load of the system, right? In, let's say, the program should handle million requests instead of high million people to execute the program at the same time. We can use this kind of tool, fork the programs, fork the process into like million, and do the load testing with just in one go, right? So that's the performance testing tool, okay? What else? API testing, Postman is very famous as well. Okay, that's all. Test case management, there are a few tools to manage the test cases as well, okay? And there are lots of service. This is the companies that offer like outsource testing to do the testing, right? So some of these are like a consulting firm, Accenture, Deloitte, Wipro is very famous as well. Yeah, Tata, Infosys. Yeah, these companies are very famous. Okay, right. That's an outsourced company. And again, when we hire someone, right, to this company, the service, testing service, they need to write the test plan. What do they want to test, and what are the test deliverables? Otherwise, we won't pay $1 million anyway. Okay. Yep. Mouse. Okay. Yep. Once we test the software, of course, the goal of the software testing is to eliminate bugs, but to eliminate it, we need to discover it. And once we discover it, we need to report it. to the developers, right? So normally we use the issue tracking system, okay, to manage the issues. For example, Atlassian, this is an Australian company, very popular. Bugzilla is normally used in the open source software system. For example, Eclipse, IDE, that kind of thing. GitHub, they offer the issue tracking system as well, that feature GitLab as well, okay? Why do we need the ITS or issue tracking system? First is to record what are the bugs, whether it is open, what is their status, who reported, who fixed it, and how long does it take to fix it as well, right? And then we can track these kind of issues. Okay, when, who, how to fix the defects I mentioned before. And it's about knowledge sharing as well. Sometimes defects are created and they are fixed, and it can be and later on we can understand, learn back from the previous defect as well. What went well, what went wrong, that kind of thing. Is about knowledge sharing. We fix this bug with this way. That's a knowledge sharing to the other developers as well. It's a lesson learned, right? It's everything. We need to use it. Okay, and the figure on the right is just a general life cycle of one issue, right? One issue report, one bug, okay? Normally, we create a new bug, create a new issue. That's a new, okay? New, let's say here, new, okay? And once we create it, as a, let's say, customer created, the probably project manager should assign, okay? Assign to some developers to fix it, okay? And then the assignee, they need to resolve it as well, right? Once it is done, or it is verified by someone, let's say project manager, QA verify or whatever, then if it is good, then it can be closed. Otherwise, we need to reopen it and try to fix it as well, or find another person to fix this bug, okay? That kind of thing, yeah? So that's a general life cycle of the defect report. And yep, mouse. Okay, but how to write the bug report effectively? If we generally, this is an examples of the bug report, right? And if we just say, hey, look, developers, the software is crashed, then as a developer, what should we fix it, right? Crash because of what? They don't provide any details, and they cannot fix anything. That's why writing a bug report is an art and also a science as well. And this is just a general guideline, right? So that means the bug, the title should briefly describe the bug. For example, the calculator module, they provide incorrect results of the multiplication, right? This is an example of the bug report. And to ensure that bug can be reproduced and we can simulate this kind of bug as well. We, as a bug reporter, they should provide the step, describe the step to reproduce the bug as well. For example, okay, go to this URL, click this button, select this, type this, and click enter, and it shows like this, right? Or in the calculator, open the app, we input this one, type this one, it produce output like this, which is not what we expect, right? That's how we reproduce the bugs. What are the results of the behavior, and what are the expected behavior as well? This is the actual output, but it is different from the expected output, right? For example, 2 multiplied by 4 should be 4, but in reality, the calculator app returns 5. What's wrong? So that's what developers should discover, right? And screen recording or the screenshot, maybe it is optional, but it could be helpful as well for developers if they want to how can I say, reproduce the bug, right? If the bug is related to the UI, that would be helpful, but if it is the functional bug at the coding level, then maybe it's not needed, okay? Sometimes the technical data, console log, or that kind of thing is needed as well. System information, if we talk about the compatibility issues, the bug happens in the, let's say, one mobile device, but it does not happen in sorry, like if the bug happens in the Android but not in the iOS, so when we provide the system information, it might be helpful as well. Okay, test data, what do we test and what is the potential impact? This is a general guideline that is that we can use. Okay, and it some people also do research in this area as well. For example, Thomas Zimmerman, he's a senior principal researcher at Microsoft Research, right? They try to do research about what makes a good bug report, what is helpful, what is not helpful, what should be, what information is needed for developers. If you are interested, you can check this kind of paper publication as well. And that's the examples of the Jira and the GitHub and the GitLab issue report, right? Yeah, the more information that you provide, it will be helpful to the developers who fix the bugs as well. All right, that's all. That's all for the 1 hour lecture today. And this is a summary. As I just want to recap again. As I mentioned earlier, software testing has 4 levels: unit testing, integration testing, when we combine multiple units together; system testing, focus on the no, not focus, include the non-functional as well; and the acceptance testing, when we consider the end users, the client, whether the software meets the client need or not, right? And then there's a 4 levels of the software testing, and because in reality, software is very large and complex. That's why we need a systematic approach, a plan to test the piece of software. We need SQA plan. Inside the SQA plan can have the testing plan as well. Testing plan will describe what is the purpose of the software testing, what is the scope, what do we test, and who to test it, which technique we are going to use, that kind of thing, right? And to test the software as a agile software tester, normally starting from the requirement, okay, we should shift the testing activities to the early phase of the software development as much as possible. From the requirement, we write the user story, write the acceptance testing. Given this user story, what should we test in order to meet the requirement for each of the software, acceptance testing criteria, right? We break it down into the unit level, functional level, decide the test cases, what is the expected input, what is the test input, what is the expected output, what is the actual output. We compare expected output and the actual output together. If it is the same, it is pass. If not, then fail. Okay, then yeah, that's a test case, we execute it. So that's all. We try to focus on, follow the TDD approaches. We try to write the test before the coding. Any questions so far? No questions. So I hope that everyone enjoyed the lecture, and then I will see you in the studio. All right. Have a good day, everyone. Yeah. Bye-bye.